Hey there, coding session time. Welcome. Continuing with Bangalang, as always, the low-level explicit compiled procedural language for the CPU and the GPU that we're creating. Last session what did we do last session? Oh, that's right. we added it so that you could output things a little bit differently. So I've got some output here that's like some JSON output that our compiler outputs. So this is basically the AST, it's the whole tree of the program. And we can also output the compute shaders that it creates for the kernels when we're running on the GPU, which is really great for debugging. One thing I did while I was doing that was I broke the OpenGL example. Because I was only running the build command and it builds fine, but it doesn't run. Interesting. And that's because I was destroying the string builder. I was doing a deferred destroy, which I thought would be fine. But I think I remember this from before actually, because I do this. So this is the string builder, this output thing. And I go to string to set the value of this. We're creating some AST which will hold the compute shader in a static variable. But when we exit the scope and this defer call happens, it means that also the toString that we got from here is like basically the memory is freed. So then it gets over rhythm with other shit and then it doesn't work. So the fix is just that we don't do that. And I think we can run it and it should work fine. Yeah, there we go. And I do think I remember this from a while ago that there was a reason that I didn't destroy it. So yeah, that fixes that. And now for this session, what I want to jump back into actually, I'm going to shut my door. I want to jump back into some unsigned integers because I like unsigned integers. It took me a long time to add them to the language, but I do like them. They are my friends. I feel like a lot of the time when I want an integer, it's just I only want a positive integer. There's not many use cases that I have where the integer needs to be negative as well, I find. So I like unsigned integers. So I want to sort of use unsigned integers in a few places. We've got a couple of tasks in here related to unsigned integers. I think one of them is just use them where it makes more sense. So I want to do that within the standard library and also within the example code. And there's also this where, because the indexes, when we're indexing into something, we do bounds checking, right? And because at the moment indexes are kind of treated as signed integers, which like for an index doesn't make sense. It means that we need to check for above like the upper bound of the array. And we also need to check for less than 0, which is not great because then we do 2 checks to see whether it's within bounds. But if we have an unsigned integer, all we have to do is check that it's not above the upper bounds. And if it was a signed integer that we passed in and we interpret it as an unsigned integer, it still works because the way numbers are represented with it's 2's complement for signed integers. Basically, it means that the positive part of a signed integer, all of those values will be exactly the same as the equivalent values in an unsigned integer. So they're all the same. And negative numbers in a signed integer just become very big numbers in an unsigned integer, which effectively means that all negative numbers will be above the upper bounds. So we only need to check that it's above the upper bounds. So that's the thing I want to do. And I happen to be aware of some problems we're going to come across because the conversion code is not good. So I might actually just go straight into that because I know it's a problem and see if we can improve that. That must be in generation. I think we need to improve the conversion code between unsigned integers. This is it here. Yeah, we're saying if the source is an integer and the destination is an integer, this is our conversion code. And it's not good. It doesn't work for a lot of cases. We really should write some tests for it, like to test, but that would take a while, you know, because we should really do like a test for every possible conversion between different sizes, signed, unsigned, floats, all of this we should do. And I don't know that I have time to do that right now because I want to get some other stuff done. So the testing takes a back seat as usual. But the first thing I want to have a look at here is there's these two instructions. Move zero extend, move signed extend. So those instructions are for moving from a small register to a large register. And zero extend is what you would do for unsigned integers. All you need to do is make sure that the upper part of the register is 0 when you go to a bigger one. But for signed extend, it's different. You need to put something, I don't know what it is, something special up there. So you need a different instruction, which is great. But if we go here to the listing of the instructions, we see that for zero extend, they specifically say, and this is really specific to this instruction, normally they're not this specific, but the source needs to be 8 or 16-bit, and the destination can be 16 or 32-bit. So notice that the destination cannot be 64-bit. And for this one, the source can be 6 or 18-bit, and the destination can go up to 64-bit. With signed integer, it makes more sense, I guess. And with unsigned integers, because it's zero extend, it's kind of handled implicitly. The upper part of the register is kind of implicitly zeroed out, so you don't actually have to do anything, which is why they omit something here. I don't know why they don't just let you do it anyway, but anyway, we kind of need to conform to this. Make sure that the source is small and the thing is big. And if it doesn't meet these conditions, I believe that means it's basically a no-op. So even for signed integers, if you're going from a 32 to a 64-bit register, I guess that's a no-op because they're saying that it needs to be a 16-bit source. Yeah, that's interesting. Okay, anyway, let's get onto this. So I think we want to model those conditions better. So yeah, we want the condition for signed extend. I kind of feel like, now let's do zero extend first. So I want to zero extend if either of the numbers are unsigned. Actually, let's make that a condition. unsigned extend, and then do they call it unsigned or do they call it zero? They call it zero extension. Zero extension and source size is less than 32 and dest size is less than, no, it's not 32 because this is bytes, so it's less than 4 and destination is less than 8. 4, yeah, less than 32. Oh, and this needs to be moved from there to 16 or 32. So yeah, so it just needs to be less than 8. Okay. I think that's right. That means that we do a zero extend because that's what is supported. Else if not zero extend, and we have some different conditions here. So not zero extend, the source is the same condition. Needs to be less than 32-bit. And this, well, I guess we don't have a condition here because it could be any size, right? So it's just like that. That's how we do those ones. I see, maybe we should actually be doing this up here, you know? I think this is where I kind of intended to do it. Kind of flatten this a bit. So we know they're both signed. No, we know they're both integers. So we do this explicit zero extension, or we do this explicit signed extension if these conditions are met. Now it just says, like, if we're not coming from a register, then just make the destination the source, which is not great. I mean, it is fine for immediates. We can just make the destination the immediate. But if we're coming from memory and we just say, well, the source bit of memory is the destination, the problem is, like, so say we had a 32-bit integer in the source piece of memory, and now we're converting it to a 64-bit integer, but we're just returning the same memory address, which is going to then overflow into some other data, and we're going to get a different number. So we need a special case for memory. I guess because we've flattened this, maybe we shouldn't have flattened this. Like, all of this is for, like, I do think, like, all of this is for when the size is bigger than the destination. We're going to have to do some more down here. Maybe I'll make that more clear to do. But if we're talking about the destination bigger than the source, this is where we need to do this stuff. So if the destination is bigger than the source, and we're coming from memory, then we need to do a copy, basically. So we want to copy, I guess we pass the context. I want to copy from source to, well, I guess to this destination, right? We have a destination prepared. So let's copy to that. What else do we need to pass in here? Type node and a comment. The comment is convert, I guess. And the type node would be the, I want to say the source type node, because that's the amount that we want to copy. So let's try that. So now if we can't go to an immediate. Well, no, we know that we're going to a register, right? That's our destination. We're always copying into that, I think. I think everywhere copies into that. But if the source is a register, well, we can either copy, maybe we will copy also for a register. If we do copy for a register, for an immediate, I feel like we can just say the destination is the immediate. We just keep it as the immediate. We don't need to do a copy. And for a register, we really shouldn't need to do a copy. It should be a no-op. It should be a no-op. So no, I'm going to do this special. If we're coming from a register, it should be a no-op. But we're going to a bigger register. And the thing about, I think this is a mistake I made. So my locations, my register locations, if we go into here, like for, this is a, I think this one is a numbered register, right? Yeah, we're passing in a number, so it's a numbered register. It produces something of type register, and the name is like R something B or W. The fact that it has this encoded as part of the name, it means that it's not just an address. It's implicit, well, not implicitly, like, yeah, well, it's kind of, it's an address and a length and a size, you know? And I don't think I should have done that. I think the register, when we're talking about a location, I think it should just be a location. It shouldn't include any size information. But for registers, at least for general purpose registers, currently they include that information. That's a problem. Because, where's my, here we go. Because really what I want to do is I want to say dest is a register, and it's like source dot register number. And what else did I put up here? Dest type node. I mean, yeah, the reason that this type node is being passed in is because that gives us size information, right? Well, it also tells us, you know, for floats you should do this, but it's being used for size information. So this whole thing is not great, but I think I'm going to do something like this for now. It's a bit hacky, but if I fix this properly, it's going to be a decent refactor. So I'm not going to do that right now. But this is the kind of thing we want. So I think that covers all the bases. So I think these three are for when the size is, when we go into a bigger size. this would work regardless. It's just saying use the source register, but adapt to the correct size. So this would work for No, yeah, we need to do this extend stuff. So this would work for the same size or smaller, or anywhere that doesn't meet this criteria. So that's not specifically for bigger, and this also. So if the destination is not bigger than the source, then this would work for memory, because we don't have that overflow problem, and it would work for immediates. Always works for immediates. So I'm just trying to think through the logic here. So I think actually I can take this away. And I'm going to say that these three are for when the destination is bigger than the size. Now I think to keep it simple, I just want to keep it flat. So I'm just going to add this. So destination is bigger than the size, and our extension criteria, or if the destination is bigger than the size and we're coming from memory, then we need to do our copy. And yeah, otherwise we just adapt our register or we grab the memory/immediate. Okay, I think I'm happy with that logic. We need to do this hacky little fix first though. So for that we need to hack our location struct, register number, and register name. So that's going to store the register name without size information and the register number without size information. Really, it should be in these two values, I think. And we should make it so that locations don't need to take they don't care about type information. It's only when we go to do the to operand that we need to do to convert it to something like the full name. But anyway, for now, so a named one is going to have what's this name? Names with, yeah, so that's the original name we passed in. I think that's what we want, and we'll just give it a number of 0. See, because these names have these suffixes or prefixes which have size information. That one didn't need any, but that's fine. And then here, there's no name, but we have the number. So we're just going to add that, like so. And what have we got up here? These are the other types of location, which don't need any of that information. So let's put empty. Okay, so I think that should mean that we have this now and this should work. So I think our conversion logic is solid now. Something tells me it's actually not solid. So let's have a look for convert. In here, start from the top maybe, and see if anything looks wrong. I think these float conversions are going to be fine. We didn't change float stuff. Going from memory to a register should be fine. The register has the size information, so we don't need explicit sizing in here. That's the same. Floating point stuff. 0 extend from 8. I believe the D is double, so this is 32-bit. 8-bit to 32-bit 0 extend. 8 to 32-bit 0 extend. Let's just have a look at those locations and make sure that I got that right. So D is 4 bytes, yes. So byte to 4 bytes, that looks right to me. And this is memory to a register. So that also looks fine. So I don't know what the problem is there, actually. I didn't see any conversions that looked dodgy. Yeah, memory to register. This is actually, that looks like memory. Well, I forget. No, that's dereferencing. Okay. Pretty sure that's dereferencing. Okay. What have I done wrong? What is this going to produce? So we're talking about integer to integer copy. Is it register to register? No, the source is memory. Ah, so that's actually this. I don't think if the source is memory, then we would have, sorry, I'm getting lost now. We would have this pattern, right? This is where the source is register. This is where the source is immediate. So we'd have that. Let's have another look in here. So that's a memory address. So this is, I'm a bit rusty with my, is this actually memory? IRSP plus 60 square brackets. I feel like square brackets is dereference. Yeah, it's dereference. So that's not memory it's talking about. It's an actual location. But does that mean it's a memory location? I think it is. Yeah, anything with an offset is memory. That is a memory location. So didn't I just say that memory, if the source was memory, we would get something like this? Did I not say that? So why are we getting something different? Must be integer to integer, otherwise it wouldn't go in. It wouldn't be like that, right? So if the destination is a float, then we do this. Or if the source is a float, so we have all this convert like this. So the source and destination are integers. Let's say converts. I just want to be sure that that's what's producing it. Yeah, that's producing it. Huh. Interesting. Oh, the destination is a register. Yeah, I was only looking at the source stuff. The destination is a register. So that's why. So it's actually doing this move. That makes sense. So it's effectively doing this. Do we need to provide size information or something? I feel like the size comes from here. Doesn't it? I don't think, I mean, we can try and add %s, I think it would be the operation size. Mismatch in operand sizes. I guess it would need to be dest size. Oh, wait a minute. That's the problem. This is bigger than the source. Right, so actually, okay. I think I've caught on to this. So actually we need this destination to be register num source type node. So it will go to the size that is the same as the source piece of memory, because if we try to copy it to a bigger one, we still have the problem that we're copying too much. And then again, we need to say that the destination is, yeah, then we need to say the destination is that, which is already true. Right, so we just need to copy to a smaller version of the register. I think that's it. Hey. All right, so yeah, we needed to go to the D, not to the non-D. See, we copied to R13D, but then later on we reference that register as R13. So this is the 32-bit version, this is the 64-bit version. And the way registers work is it's the same bit of memory, but this is just like the lower part of this register is this register. So it's the same memory, it's just that we're referring to a bigger portion now. And this will implicitly, this is what I was talking about, the implicit stuff before. This implicitly zeroes out the top part of the register. So when you refer to it like this, it works fine. Okay, so the conversion is at least working enough that our program runs. So now, dare we play with some stuff? Where do we have some signed integers that don't need to be signed? I think there's like this frame count is fairly isolated. So I think that's a good place to start. How's that? Wow. Index 0 is out of range. Oh, yeah, that happens sometimes. It's really weird. Like, we don't get past any arguments to the program for some reason. Okay, now this is even weirder. Where are we? Assignment. The default case. We haven't supplied an allocator. The right-hand side. We don't have a right-hand side on this line, if that's what it's talking about. I mean, we didn't have one before, right? If I just have I64, everything works. But U64, oh, okay. I don't know what was wrong there. Okay, let's try up here now. So if that's a U32, make these U32s, just make all these U32s. This has to be an I64 for now. We need to deal with that separately. Yeah, I think that's it. Let's see if that works. Okay, good. Where do we use I8 in Bangalang code? That's fine. What about I16? Nowhere. I32? Lots. What about I64? Also quite a lot. Let's start with I32. So there's like threading, OpenGL. Yeah, OpenGL is, I guess, a bit of a separate beast. We need to check the documentation to see whether, because I just put I32s everywhere, well, signed integers everywhere, because at the time that's all I had. But some of them are probably supposed to be 64-bit. So all this util stuff is OpenGL as well. There's Boomstick. Global, so that's allocators. That's probably a bit more complicated. I feel like this is a dangerous place to start, but let's try at the very bottom. Let's start from the bottom so that that window does not get in the way. Okay, what happens if I do that? Not compatible in threading. Threading 55. Yeah, because syscall is expecting. See, so effectively we need to change the syscalls. So this is probably not going to be great. Count. See, like the count can only be positive, and what it returns, I think, is a file descriptor. I could make like aliases, so it's a file descriptor type, but that's fine. So all this kind of stuff, I'm just going to make length flags. See, I don't see any reason for this to be signed. Yeah, I tend to think of it as like there should be a reason to use signed, not a reason not to use signed, you know? Seconds max, that's always going to be positive, right? Expected. Well, expected, I think I want to make these U32s. So it's a pointer to something, and this is the value that we expect that value to be. So I'm going to make that should be U32, I think. And we'll up it to U64 because that's what syscalls expect. But I mean, that should match that. Those two should match. Okay, I think that's all the syscalls, so now we should get like a lot of errors. Oh. Maybe we only get a few at a time. All right, so what do we got here? A2I, so it's a core strings 6. Because message is a string. String is a slice, and the length of a slice. The length of a slice is an I64. This is getting into dangerous territory now. Let's check. Let's check the Odin code for I64. Bunch of tests. So there's not that many references, but sizes, yes, slice, address, size plus 8, which is U64, it's the length. Index type node, length type node. So both of those should be U64s. Yeah, those should be that. I64 is the size of an allocator. So I'm going to make that U64. This is also an allocator. Allocator type. It's adding a return. Which I'm also going to make a U64 actually. What is this? Is this more allocator stuff? No, this is a type check conversion call. Any float goes to F64, I64. Yeah, so this I don't think should be unsigned. That should be signed. That's sort of like default types for numbers. I think we default to signed so that it can handle negatives. Length. So this is getting the type information for the length of a slice. So this is the problem we were kind of up before. Size. This is the size of a type, I think. Yeah, if is type. So because you can go dot size on types, the size should be a U64. I mean, even that's pretty excessive. Like, you're not going to have something that big. Okay, and the length of an array or a slice is a U64. When we're indexing, we're upgrading. Yeah, so this is where when we index, we should upgrade to a U64. I think there's 2 of them here. Like if you're slicing, then there are 2 indexes that you supply. What else we got here? Length type node U64. Isn't there? Didn't we have like, yeah, up here? Oh, that's x86 utils, and this isn't type checking, so that's probably why. Upgrade types to, so this is any number. So again, this is signed. This is when people just have number literals. They don't specify a type. We sort of upgrade them to I64 in some cases. These are just lists of types. This is the interpreter. This is a different project. Okay. So I think that's all of the Bangalang code. In here, probably it's complaining about this one now. Yeah, because we changed that there is expecting a U64. What's vertex count? It's triangle count, so it's a U32. So we upgrade it to U64. Oh, this does not have any. But after that, it's complaining that triangle data is not defined. So I think it's going to be something in here. It could be like gl.heap, some generated code or something, and that's why it doesn't have anything there. If we go to gl.bang, heap, the size should be a U64, I think. So probably have to cast it I64 here. And like I say, I'll need to change that later. Maybe these types in these OpenGL procedures might need to change. Let's see if that fixes that though. Looks like it did. So os.bang 9. So these are U64s now, so that should output a U64. This should be a U64. That should be a U64. Okay, let's close some of these. I think we're making progress here. So now we need util .bang. This is mostly OpenGL stuff, so I'm kind of surprised. 53. Because the length and the error length. Get C string length. I feel like that should be a U64. How's that? I think that fixed that. Boomstick. Boomstick 32. So this length is a U64, so when we loop over it, it should also be U64, and indexing should work fine with U64 also, so that should fix that. Threading 136. Okay, so it's expecting this to be a U32 now, few ticks wait. So thread pool working should be U32. Mutex should be U32. I mean, these counts. I'm going to change to U32s as well. This is going to create a world of hurt, isn't it? But I think these should all be U32s. This is not going to cause an error, but I want to change those to U64s also. All it's doing is getting the size, so it'll be the same regardless. Like so. Is there anywhere that we say I32 here? Because it probably needs to be changed. These are U32s now. Mutexes are U32s. I think the waiter, yeah, that's effectively a mutex, so that's U32. Okay. What's down here? Oh, so to do. Okay. I think that's threading kind of sorted. Boomstick 52. Data.length, that'll be a U64 and that'll be a U32. So let's convert it to U32. That's U32. It's an OpenGL thing. Kernel.length, that's going to be U64. Okay, I think that's all good. Worker count should be a U. That's OpenGL stuff. That should be a U. Okay, let's see how we're going here. Threading 10. Oh. What? Oh, this is broomstick 10. Threading 10. Let's say, oh, this is compare exchange. So that's globals. Where did I see this? It was like in Linux. Yeah, it's like this expected replacement. Let's make them all U32s as well. Where, I think it's in here. Here's the actual implementation of it. I think that should be fine. Okay, let's keep going. What do we got here? More stuff in threading at 149. That should be a U64. Strings. Strings. Let's just have a look through, see if where we see I64s or I somethings. Yeah, this I think should be an I64. This is the culprit. That needs to be U64. But A2I, I think needs to output a Y64. The factor times factor times 10. I think that can be a U64. But we need to multiply it by an A64, so let's make it an I64. It's never going to be that big a number. It should be quite small, actually. I think that's all of them in there. First param must be I32. What is this for? Ah, this is like some validation of the GLS cell. Huh. Okay. But I think the first param should be U32, actually. I forgot that I had that there. Oh, panic index out of bounds. This is the indexing thing I was talking about, so we might have to tackle that at the same time. Opening a can of worms here, I think, hey. So this is this index. When we index into things, we should also have a look at type checking. Yeah, so we changed to U64. Is there anything else we need to change here? Index out of bounds. So we only check that it's greater than or equal to length here. We don't check for negatives. Even though this is kind of like someone could have put a negative in there, I don't think we validate that properly. Yeah, but I feel like that's a separate thing. Maybe? Maybe not. But I think this is okay, this code. And the x86. So this is where we're doing, see, we're doing a couple of comparisons, checking that it's greater than equal to or less. So actually above or equal is the bad one now. If it's unsigned, we don't need to do less. That's the idea. I don't think we actually need to do anything other than that. We're just treating it like A instead of G. It says treat it like unsigned instead of signed. I think that's all there is to it. So I think here we can also do JA and slice length location, I think is, yeah, we need to set that. We're creating a slice. But this comparison here, maybe it can go like in there. We need to do that regardless. And I think JL makes sense there because we're kind of, yeah, we're comparing. But the length, this should not be less than 0. Yeah, okay. But the length, I'm not sure actually if that does make sense. Like it would just be, because we're talking about treating these things as unsigned, which means that it would actually just loop around and you would get a really big length. Maybe we can just say JB. But we need to compare the two actual locations. I don't know, let's put a note to review that because I have a feeling that's not quite right. But let's see what happens if I run it. Still panic index out of bounds. I mean, there's so many things that it could be now because I've changed so many things. That's the danger. But what we can do is, you know, like comment out a whole bunch. I think the syntax highlighter doesn't realize it, but that's actually legit. Okay, it's still panicking. So if I go up here, still panicking. Is it the boomstick in it? Yes. I didn't mean to debug then, but that's the boomstick in it. Has problems. GLSL kernels is generated by the compiler. That's why we have it none. That's a very special kind of allocator. And it is like, what happens if we comment this out? Ah, so it's actually here. If I comment that out, no error. If I uncomment that, no error. Okay. If I comment that out, error. Okay, so it seems to be in this get CPU core count. Seems to be where it's happening. Okay. I was just about to say, I don't see where the issue is, but what if I go like this? No error. Just keep doing this, you know. So this part's fine. If we take out the if, that part's fine. Well, maybe we test just this part. That seems to be fine. This line, that's fine. Panic index out of bounds. It was that line, wasn't it, that caused it? Yeah. Okay. So it's this A to I. Must be inside this A to I. Here's A to I. So we pass in a string. We go length -1. And we keep going down until... Oh, index is greater than or equals 0. That's always going to be true for an unsigned index. Oh no, we have like here, index equals 0. Oh, do break. But the problem is that we're going to go, when we subtract 1 from 0 on an unsigned integer, we're just going to get to a big number again. It's just going to wrap around. So this condition's not going to work. So actually it's going to look a bit weird, but we need to say index is less than length, which is the same condition you would do if you were going forwards through the loop. We're going backwards through the loop, but it's still true because we start with less than length. But we need to stay less than length. That could be it. Is there anything else? This is the only thing I changed, this index. So it's got to be on this loop. Yeah, so then probably what happened was it got here and this was where it was the index was out of bounds. Yeah, no more error. Okay, good. Where were we commenting out? Looks like we uncommented that. We uncommented that. Hey, we're in business. Okay, wow, we changed a lot of stuff. I'm kind of surprised that all works. Debug, we didn't. This doesn't do anything really with integers, but I thought it was going to be, I mean, that was a mission, but I thought it was going to be more of a mission actually. Correcting the OpenGL unsigned stuff we can leave for another time. I think that's pretty cool. One thing I want to double check. I mean, we did get index out of bounds errors showing up, which is good. Let's just run the playground. Playground seems to run fine. But I want to do just a couple of tests like, well, we have these slices here already. So what happens if I say my slice 5? You know, that should be out of bounds. Panic out of bounds. What if I say -1? panic out of bounds. But if I say like 0, that's fine. Maybe I can even do like os.exit so that we see what it returns. 0. Actually, I was thinking about my/2. But I checked with length 5. I checked with index 5. I was looking at this slice, which has length 5, so index 5 should be out of bounds. So 2, that's what I expected. 1 plus 1. And if I do like 0:2, or 1, say 1:2, 0, that should slice these two values, so it should be 2. Yeah. Well, a little bit ambiguous, isn't it? So let's change this. It should be 4. Oh. All I did was change this, right? Right? Yeah. What? Oh. Okay. Yeah, that's what I expected. I'm not sure what happened there. But that all seems good. If I put like 7 here, that should be out of bounds. Oh. That's not out of bounds. That's when we're here, right? The end expression is not null. That means that we do have a number here. We're not using boundless. So this comparison should say that if when we compare that 7 to the length, the child length, so the length of the thing that we're slicing, we should see that it's above it. Okay. It's not another one of these weird. Okay, maybe it's just that the file wasn't saved or something, because that was the previous output. So it seems to be. Whoa, what? Sometimes it panics? Oh. That's a bit scary, actually. There's something non-deterministic going on here. Sometimes it passes and sometimes it doesn't. And whenever it does sneak through, whoops, it finishes with exit code 4. Which is correct. It is correct, actually. I guess it's just taking memory out of bounds of the slice when it creates this slice. So yeah, that is correct. But what's not correct is the fact that it gets past the bounds checking. If I go to playground, and we scroll down a bit here, see if we can find this. I guess we kind of need to find the next procedure, or if we find the default exit, that's the OS exit that we call. Here's some like panic out of bounds stuff. so this is the expression. So let's split this up maybe. And then maybe like F0, not Z0, F0, F0. I wonder if this is going to come through sometimes. Interesting. I mean, because it's kind of random, it's hard to know whether this is like actually not a problem with when it's like this. But I think with how often it was happening before, it seems like it's not a problem like this. It was when it was combined together into a more complex expression that it sometimes didn't work. Interesting. I wonder if that worked before. So now if I go works. Is it just going to work every time now? No, didn't work. Okay. So what if I do like this? So it's just a 2-line setup. I have a feeling that it's when this and this are like right next to each other that it could be a problem. I don't think it's a problem I'm going to solve right now because I think we've spent enough time on this for now. We're kind of finishing up this session. But yeah, see, that seems fine. So that's fine, but that's not fine. Yeah, that's something that I need to take another look at. But, you know, I'm pretty happy with how we did. We have just a whole bunch of unsignedness, unsigned bounce checking, which may have broke things. I think the first thing I would do is I will like roll back this commit, and then I'll check to see whether this is an issue in the previous commit, because if so, then it's something we changed. But I'll do that offline. But yeah, I was just trying to summarize. So we have maybe working unsigned indexing, and just in the standard lib, and also in, we didn't do it in, I mean, the playground is like, you know, you just uses all sorts of stuff. It's not, doesn't need to use anything special. But in the OpenGL example, we used it. The only other place to maybe propagate this stuff is the OpenGL bindings. But I'm pretty happy with that. I think that's good. And we got the conversions improved. I think that's a big one that we need to test. Okay. All right. Enough for today. Thanks for stopping by. Have a good one. Ciao for now.